Question of the Week from the Naked Scientists.
Hi there, and welcome to Question of the Week. I'm Eva Higginbotham, and this week we've been scrubbing up to answer this question from William.
When a bar of soap gets used a lot and gets smaller, it seems to struggle to form suds properly. Is something other than just a smaller surface area going on?
Makes me want to wash my hands just thinking about it. Alan Calvert from the forum said, "My guess is that most soaps include volatile and easily soluble components that aid lathering. As the bar shrinks, its surface-to-volume ratio increases, so these components are lost more rapidly. But what do the experts think?" Philip Broadwith, business editor at Chemistry World for the Royal Society of Chemistry, gave us this answer.
The reason a small soap bar doesn't make such a good lather is mostly down to surface area. To form bubbles, you need to dissolve soap in water and then agitate it. And with a solid bar of soap, you can only dissolve the soap molecules at the surface of the bar. With a large bar, the water on your wet hands is in contact with quite a large area, so can dissolve quite a lot of soap quite quickly and make a generous lather. But with the smaller bar, your surface area in contact with your hand is smaller, so even if you have the same amount of water on your hands, the soap is released more slowly.
Paul Danauer, Associate Professor of Chemical Engineering and Materials Science at the University of Minnesota and soap enthusiast, had this to add.
A three-dimensional object like a bar of soap that shrinks to half its original size actually only has 1/8 of the original surface area. People are not scrubbing with the bar that much longer, and the perception is that they are not getting as much soap transferred to their hands.
Right, so by that math, to use a bar of soap that's gone down to half its original size, you'd need to be scrubbing your hands for 8 times longer. No wonder we get impatient.
A second impact is the perception of the bar by the hand washer with time. Soap bars are made of heavy molecules, such as soap molecules, but they also contain light components that enhance the hand washing experience. A person washing their hands is aware of some of the compounds that add color and odor, but other components are added to have additional benefits, such as stabilizing a foam or eliminating the effects of hard water.
Hard water, like we suffer in Cambridge, contains metals which bind to the soap molecules and stop them from being able to clean properly. Soap manufacturers add special compounds called chelants, which will bind to the metals and protect the soap molecules. But what does this have to do with getting a good lather from a small bar of soap?
Over time, these lighter compounds will evaporate into the air or preferentially leach into the water faster than the heavier soap compounds. The end result is that the smaller soap bar is less effective later in its life at forming stable, lathery foams that are good for washing your hands.
And Philip has an extra tip for the frustrated hand washers out there.
You might be able to get a better lather by carefully adding more water to your hands, but that's quite difficult to do without washing off the existing lather. Alternatively, when the bar is small enough, try rubbing it over the backs of your wet hands as well as just the palms, so it's exposed to more water to dissolve more soap.
So, there you have it. There is more to the frustrating experience of washing your hands with a well-worn bar of soap than just a smaller surface area. Next time, we'll be answering this question from Marcus.
How can oak trees and others grow so huge without making a great hole in the earth? Where does their mass come from if not from the dirt?
But what do you think? You can email chris@thenakedscientists.com, find us on Facebook, tweet @nakedscientists, or join in the debate on the forum, which is nakedscientist.com/forum.